Hi, I'm Stephen Oliver. Welcome to the Navitas booth at APEC 2022 in Houston, Texas. Here this week, we're very pleased to announce 40 million Navitas units shipped with 0 reported GaN field failures and a 20-year warranty. Let's start with the technology. Navitas GaN power ICs are GaN on silicon, and we use TSMC in Hsinchu, Taiwan, using their 6-inch 350 micron process technology. This means that even though GaN is an amazing new material, it uses old, available, low lead time technology. Let's talk about the differentiation, the highlights of the Navitas GaNFast power ICs. The fundamental advantage is the monolithic integration, that's same chip integration, of GaN driver with GaN power. Here you can see that we go from a discrete implementation with competitor products with all of these extra components, increasing complexity and risk and cost and size, to a completely integrated half-bridge GaN power IC from Navitas. On this case, we look at a GaN to GaN comparison. In this case, a competing product at only 65 kilohertz. And you can see the size of the transformer and the bulk capacitors and the output capacitors. This is 23 millimeters tall. By increasing the switching speed to 400 kilohertz using the GaNFast power ICs, we can go to a planar PCB mounted transformer, and this is now 3 times smaller and lighter than the original design. Let's talk in more detail about our GaNFast power ICs with GaNSense technology. In this case, we're looking at a 120 watt silicon-based laptop adapter. That's a big adapter. We compare that with the latest generation 120 watt unit using GaNFast power ICs with GaNSense. Now let's explain a little bit more about that. We start with the silicon design, and you can see on the inside we have very large magnetic and capacitor components. Very large design because this is also low efficiency, so you need a big space to get rid of all of that heat. With the GaNSense approach, we have high frequency operation. We also have what is called lossless current sensing, which means this unit is far more efficient than the silicon version and can be smaller and lighter as well. So here, this is a Xiaomi 120 watt charger in 1/3 the size of the original silicon, and this is used to charge smartphone ICs from 0 to 100% in only 17 minutes. That's ultra fast charging. Back in 2019 APEC, we were able to demonstrate the Mu1 45 watt charger and also the Eggtronic 65 watts. In only 3 years, the aftermarket range has expanded, and when we include all of the OEM designs, we are now at over 170 different chargers in mass production, with another 240 in the development pipeline. These are using the new Type-C power delivery protocol. That means they are universal. You can use a laptop charger for a phone or your earbuds. Carry one thing, not 3 things. Now that GaN is readily available and accepted by many users, customers are now looking at ways to differentiate their product. Here we see our fashion charger lineup. Also, now that large smartphone manufacturers have stopped shipping a charger inside the box, it gives the user a chance to represent their personal tastes. So now we have disposable income for generally younger people, and they can choose anime, One Piece, they can choose the League of Legends, or they can choose any number of different devices to give fun as well as lightweight, ultra portability, fast charging. Navitas is happy to announce that we are in production with 8 out of the top 10 mobile manufacturers. We can also announce that we are in development with all 10 of 10 top mobile OEMs. Here you can see Samsung, Lenovo, Xiaomi, Motorola, Oppo, Dell, all of these products in mass production and ramping very quickly. The fast charger and ultra fast charger market represents a $2 billion opportunity for GaNFast power ICs. GaN is not only a new high performance material, it is also a green material. The GaN power ICs are between 5 and 10 times smaller than the silicon equivalents, which means they are 5 or 10 times lower carbon footprint to manufacture. At the same time, when we look at how we can sustain the world and change from fossil fuel to electrical loads, gallium nitride plays a very strong role. By going from silicon to GaN for electric vehicles, we can accelerate adoption of EVs worldwide by 3 years and save 20% of road sector emissions of CO2. As we look at the CO2 cost of our customers, someone like Dell or Lenovo or HP can save 1/3 of the carbon footprint of their adapter by adapting GaN. That means that overall, for every GaN power IC we ship, we reduce carbon emissions by 4 kilograms. And by 2050, the year of the Paris Accord target, GaN could save up to 2.6 gigatons of CO2 per year. Moving on beyond chargers, we get into 3 new markets. We have solar, data center, and electric vehicles. All of these markets appreciate the small size, lightweight, and high efficiency of GaNFast power ICs. In this example, we're looking at the data centers. And here, in my hand, I have a comparison of a silicon-based 48 volt output, 400 volt input DC-DC brick, and its GaN equivalent. The silicon version is 750 watts, the GaN version is 4 times smaller and 1/3 more power. When we move to AC to DC applications, we see a prototype design by 2 PhD graduates from the University of Texas using gallium nitride power ICs to go half the size compared to the original silicon design. And in this example on the right hand side, this is the first design from our Hangzhou dedicated system design center for data center. This is a 1.2 kilowatt CRPS titanium efficiency class unit. This means this exceeds the highest quality requirement, which is compulsory by the European Union from the 1st of January 2023. At the same time, we have taken this prototype, shown it to a range of customers, with one of them declaring, looking at the bill of material, due to the efficiency, the speed, and the simplicity of integration, that this unit now, with GaNFast power ICs, is cheaper than a silicon legacy design. Let's talk about electric vehicles and the critical role that GaN can play in shortening charge times, extending range, and being very kind to the environment by reducing CO2 and accelerating EV adoption. In an electric vehicle, there are 3 places we can use GaN. The first is the onboard charger, or OBC. This converts from AC to the battery voltage. Because gallium nitride can shrink power supplies 3 times, this means that for the same size, we can put 3 times more power. That means 3 times faster charging. Another place is the DC-DC converter, where we go from maybe 400 volts DC down to 12 for your navigation system and your lighting. And the third area is the traction drive. In this case, we can take the ultimate evolution of electric vehicles, and instead of having one large motor, we can split it into smaller motors, one in each wheel. These are wheel-mounted motors. This means that we can use GaN's high speed and efficiency to shrink the size and weight of those, which reduces the wear on the suspension and totally eliminates mechanical linkages, drive shafts, differentials and axles from the car, reducing weight and reducing cost. In this example, we could be at $50 of GaN content for the onboard charger, $15 for the DC-DC, and potentially $200 for the traction drive. Down below, we see a prototype from the Navitas application teams. This is a 6.6 kilowatt onboard charger. This is being refined and the range extended. We'll have another 6.6 and 11 kilowatt and 22 kilowatt versions to show to customers in the EV space exactly how small and how fast charging we can go with gallium nitride. This quote is from our customer Brusa. These are the designers of the Porsche Taycan charger. And they have said that in the past they've used silicon. Today they use silicon carbide, but they will be going to GaN power ICs for their future designs.